In this video, we're going to look at how to go from the empirical formula of a compound to the molecular formula of a compound. So we know how to find the empirical formula, but remember that the empirical formula is that lowest whole number ratio of the atoms in a compound. Remember that we looked at the 4 compounds with the same empirical formula. Those molecular formulas are just multipliers of that empirical formula. So if you look back at your notes from the empirical formulas, you'll see that we had CH2 and C2H4 and C3H6. So those were all just multiples of the same empirical formula, which was CH2, the ratio of 1 carbon to 2 hydrogens. So how do we determine what the multiple of the empirical formula is, which multiple that molecular formula is? So usually we are given the molar mass of the compound and the empirical formula in the problem. So if you look at this problem, you can see that it gives us the empirical formula and it gives us the molar mass. And so what we want to do is we want to use the ratio of the molar mass of the empirical formula to the molar mass of the compound to find that multiple. So let me just put the problem up by itself so I have room to work it out. All right, so that's just the same problem that we were looking at. What we want to do is take the ratio of the molar mass of the molecular formula, because that's some multiple of the empirical formula, and take that molar mass of the molecular. So what we want to do, we know that the molecular formula is some multiple of the empirical formula. So it's 2 times the empirical formula or 3 times the empirical formula or something like that. What we need to do is find out what that multiplier is. So what we'll do is we'll take the ratio of the molar mass of the molecular formula and we'll divide it by the molar mass of the empirical formula. And that should give us a whole number or something very close to it. So in this problem, we're given the molar mass of the molecular formula. We are also given the empirical formula, but we'll have to calculate the molar mass ourselves. So we know that we have 1 carbon and we have 2 hydrogens. So 1 carbon is 12.01. We're going to add that to 2 hydrogens, which are each 1.008. And that's going to be 2.016. And when you add that up, you get 14.026. So we're going to put our molar mass of our molecular formula. So that number goes on top, 84.156, and that's grams per mole. That's the number of grams in 1 mole. And we're going to divide by the one that we just calculated for our empirical formula, 14.026 grams per mole. And when you do that, you find that that is a ratio, that ratio gives you a whole number of 6. And so we know that 84.156 is 6 times 14.026. So 6 times this empirical formula of CH2 will give us the molecular formula. So we just multiply the subscripts of each of our elements to give us that formula. So we know that the formula must be C6H12, because that empirical formula is that lowest whole number ratio of the atoms in the compound, and the molecular formula is just a multiple of that. The number should be a whole number or something very close to it, 0.01, 0.02, something like that. Away from a whole number would be okay. But if you get something like 6.8 or 4.5 or 3.2, you need to go back and check your molar mass or your empirical formula to make sure that it's correct. There will, in these problems, I'll expect you to be able to calculate an empirical formula and use that to determine a molecular formula. So let's look at that. So in this problem, we've got a molar mass for a molecular formula, so we know that we can find the molecular formula, but we don't have the empirical formula. We just have the masses of carbon and hydrogen in the compound. So that tells me that I'm going to have to calculate the empirical formula myself. So let's go ahead and do that. Remember, for your empirical formula, your little rhyme to help you figure it out, it is percent to mass. And we don't have percent in this problem. We already have mass, so we're going to skip that step. Then mass to moles, so we're just going to go ahead and convert our grams of hydrogen to moles of hydrogen. So we already know how to do that, so we're going to go ahead and set up our conversion factor. And it's going to be grams of hydrogen on the bottom, and then we're going to put moles of hydrogen on the top to convert. And we know that 1 mole of hydrogen has a molar mass of 1.008 grams. And when you multiply that, you get 0.4365 moles of hydrogen. And then our other one is 6.92 grams of oxygen. And we're going to go ahead and do the same thing, convert from grams to moles. So grams of oxygen on the bottom, moles of oxygen on the top. 1 mole has a molar mass of 16.00 grams. And when you multiply that, it's going to be 0.4325 moles of oxygen. Sorry about that little pop-up there. All right, so we're going to divide by small. That's our smallest number of moles, so we're going to take our other number of moles and divide by that to get our ratio for our empirical formula. So there are moles of oxygen, and when you divide that, I got 1.009, which is about 1. So we're going to call that 1 mole of hydrogen per mole of oxygen. So we know that our ratio is a ratio of hydrogen to oxygen of 1 to 1. So that means that our empirical formula is HO, so 1 hydrogen to 1 oxygen. Now we need to do the step where we figure out the molecular formula. So remember that we're going to take the molar mass of our molecular compound and we're going to divide it by the molar mass of our empirical formula, which is what we just found. I'm going to go ahead and bump this up so that I have room to write. So I hope you wrote the problem down. If not, go back and rewind. So our molecular formula, the molar mass that it gave us in the problem is 34.00 grams per mole. And we need to divide that by the molar mass of 1 hydrogen plus 1 oxygen. Hopefully you can figure out in your head that that is 17.008 grams per mole. And you might even be able to see that this is about 2. And you can see if you divide that in your calculator, it is almost exactly 2. So we know that that's our multiple for our empirical formula. So 2 times HO is going to be H2O2. So that's our molecular formula. And this is our empirical formula. And make sure if I ask you for both in the question that you identify everything, because these do have a lot of work to show. All right, let's try another one. Okay, so in this problem, we've got information about theobromine, which is a stimulant in chocolate, and it's kind of like caffeine, and it has a molecular weight of 180.18 grams per mole. So that is the molecular formula molar mass. And then it also gives me the percentages of the elements that are in the compound. So I'm going to have to calculate my empirical formula, and then once I've done that, I'm going to use it to calculate my molecular formula. So let's get started. Empirical formula first. Remember that if it gives us the percents, our first step is percent to mass. So we're going to want to assume 100 gram sample so that we can go ahead and use those masses. So we're going to assume that we've got 100 grams, so we know that 46.66% of 100 grams is 46.66 grams. So we've got 46.66 grams of carbon. We're going to convert that percent to mass to moles now, so grams to moles of carbon. At this point, go ahead, pause the video, try to work out the empirical formula, then skip ahead and check your answer. And then we'll work the molecular formula part together. If you want to try it, give it a try and see what you do with it. All right, so we've got grams of carbon on the bottom, moles of carbon on the top. So 1 mole of carbon is 12.01 grams of carbon. And when you calculate that out, you get 3.885 moles of carbon. Then for hydrogen, it's 4.48 grams of hydrogen. And that's just going to be 1 mole of hydrogen and 1.008 grams of hydrogen. When you put that in your calculator, you should get 4.444 moles of hydrogen. I'm going to go ahead and just bump this down a hair. I know that you can't see the problem anymore, but hopefully you've got it jotted down on your paper. All right, we've got 31.10 grams of nitrogen, and we're going to go ahead and convert that. Grams of nitrogen on the bottom, moles of nitrogen on the top. 1 mole is 14.01 grams. So when you calculate that out, you should get 2.220 moles of nitrogen. And then 17.76 grams of oxygen, and we're going to set up a conversion for grams of oxygen to moles of oxygen. Sorry, it got a little tight there. I was trying to keep it on the slide. And 16.00 grams in 1 mole. And when you calculate that out, you get 1.11 moles of oxygen. So let's go ahead. Remember, our next step is divide by small. Our smallest number of moles is 1.11. So we're going to take 3.885 moles of moles of carbon. We're going to divide by our moles of oxygen, 1.11 moles of oxygen, and that gives us 3.500 moles of carbon per mole of oxygen. And we'll do the same thing with our moles of hydrogen, and then we'll do the same thing with our moles of nitrogen. So we're going to divide by our moles of oxygen. And for this one, I got 4.003 moles of hydrogen per mole of oxygen. And then our next one is nitrogen, 2.220 moles of nitrogen divided by 1.11 moles of oxygen. And when you put that in your calculator, I got 1.998 moles of nitrogen per mole of oxygen, and I think it's safe to call that 2. All right, so we've done our divide by small. Now we need to multiply till whole. So let's set up our ratio: carbon to hydrogen to nitrogen to oxygen, and our ratio is 3.5 to 4 to 2 to 1. And you can see that we've got a decimal there. It's 3.5, so we need to multiply those by 2 to get our empirical formula. So 7 to 8 to 4 to 2. Make sure you multiply each of those numbers to get the correct formula. So your empirical formula is going to have those subscripts. So C7, H8, N4, O2. And then we need to find the molecular formula. So what we want to do is we want to calculate our molar mass of our empirical formula, and then we can use that number with our molecular formula mass that was given to us in the problem to find the molecular formula. So let's add up our molar mass. I'm going to bump this up again. We need a lot of space to do these ones. Okay, so go ahead and add up the molar mass for your empirical formula, and then just skip ahead and check your work. So for your carbons, you've got 7 carbons times 12.01, and that gives you 84.07. For your hydrogens, you've got 8 of those times 1.008, and that's going to give you 8.064. And then you've got your nitrogens, 4 times 14.01. That gives you 56.04. And then your oxygen, you have 2 times 16. And that gives you 32.00. When I add that up, my total there is going to be 180.174 grams per mole. So in order to find that ratio of the molecular formula to the empirical formula, we're just going to take those molar masses. So molecular is divided by empirical. So we've got the molar mass of the molecular formula from our problem, and that was 180.18 grams per mole. And you're probably looking at that going, well, those look very similar. 180.174 grams per mole is our empirical formula. And so if you do that, obviously your ratio is 1. You can have the same molecular formula as you do empirical formula. And you could just write me a note up here and say this is also the molecular formula, or you can circle this and say this is my molecular formula. So you can write it again. It's up to you. But you want to make sure that you identify it, or tell me if you just stop here, you're going to lose some points. All right? Let's try another problem. This time, I'd like you to give it a try. Work all the way through the empirical formula. See if you can set up the molecular formula. And if you get stuck, skip ahead to where you're stuck. If not, buzz ahead to the answer and check and see if you got it right. All right. So in this example, we've got lycopene. That's the good stuff in tomatoes that turns them red and helps prostate health in men. So let's go ahead and figure out the empirical formula. So remember that we are going to go percent to mass, mass to moles, divide by small, multiply to whole. So we're going to assume a 100 gram sample. And that tells us that we will have 89.49 grams of carbon. We're going to convert that to moles, so grams of carbon on the bottom, moles of carbon on top. We know that 1 mole of carbon has 12.01 grams. And for that, I got 7.451 moles of carbon. And then for the hydrogen, we've got 10.51 grams of hydrogen. And we're going to convert that from grams of hydrogen, so that goes on the bottom to cancel, to moles of hydrogen. We know that 1 mole has a molar mass of 1.008 grams for hydrogen, and when you put that in your calculator, you should get 10.43 moles of hydrogen. Our next step is going to be divide by small, so we're going to divide 10.43 moles of hydrogen by 7.451 moles of oxygen, and we are going to get a ratio of 1.399 moles of hydrogen per mole of carbon. So looking at this, remember not to round. This is when we'll multiply. So this is about 1.4. Think of 4.4 as a fraction. That would be 4/10 or 2/5. So we would want to set up a ratio. We've got a ratio of carbon to hydrogen of 1 to 1.4. And we're going to multiply both of those by 5. So it's going to be 5 to 7. So our empirical formula is going to be C5H7. So let's try another. Let's go ahead and figure out the molecular formula. We've got to first calculate the molar mass of the empirical formula. So let's go scoot this down a little bit and add that up. Just realized I didn't have the 7 there. Okay, so the empirical formula is C5H7, so the molar mass of that is going to be for carbon 5 times 12.01, which is 60.05. And then hydrogen, it's going to be 7 times 1.008, which is going to be 7.056. And if you add that up, you should get 67.106 grams per mole. Remember that that molecular formula is a multiple of the empirical formula, and so we're going to use the molar mass of the molecular formula, and we're going to divide by the molar mass of the empirical formula to get our multiple for our molecular formula. So when we use the molecular formula molar mass, that is going to be 536.90 grams per mole. And we're going to divide by our empirical formula molar mass, which is 67.106 grams per mole. And when we do that, it is approximately very close to 8. So we know that our molecular formula is going to be a multiple of 8 of our empirical formula, which is C5H7. So that gives us C40H56. Okay, so that's our molecular formula. So make sure you box it, or you just make a note to me so that I know what it is.